What I do, because we treat patients, not statistics, is things you can do to try to help. You can look at diet and lifestyle. What kind of diet? High protein, low carb, because all microvascular disease is glucotoxicity. It's sugar toxicity. That's what it is. There is something in the body called a glycocalyx. Glyco means sugar, calyx means husk. And it's a skeleton, it's an exoskeleton. It's the same as what an insect would have on the outside of them, or a scorpion, or a crab. It's the same thing as a slime on a fish. Basically, it's a biofilm. And if you go back to Pissinger, the diagram I showed you, the German guy where he was looking at that, he was looking at how that system relates to cell-cell communication. Inside the vascular system, there is a glycocalyx, a sugar protein thing that pokes out into the lumen. And medicine is aware of that, but it's kind of ignored. They don't understand what it does. So they look at it under a microscope as opposed to looking at it globally. And what happens here is, what sugar does is it caramelizes proteins, it glycates proteins, it inactivates proteins. And doctors are taught that once a sugar is glycated, it's irreversible. That's actually not true, but that's what they're taught. And if you think about this microvascular system as the heart beats, the pacemaker, the circulatory system, it's pumping, and this microvascular stuff is pulsing with that, whether it's in your liver, in your kidneys, in your brain. As the sugar begins to caramelize on the inside surface of these little vessels, instead of pulsating with the heartbeat, they begin to stiffen. Now remember from the earlier diagram, these vessels are 5 to 10 microns in diameter. One cell can go through them at a time. If they're 5 microns, if they're stiffened, glycated, caramelized, like melting caramel over an apple, and you have a 6 to 8 micron red blood cell, it's not going to get through that vessel. So the cell starts to go down the vessel can't pulsate, the cell gets stuck. And right beyond that, you have a little tissue damage. That's what they see in the brain. They call lacunar infarcts, but it occurs in the heart. And that's documented in research. They just can't treat it, so they ignore it. It occurs in the kidney, high blood pressure. So the end organ that takes the hit depends on the clinical symptoms you see. If it's in the kidney, high blood pressure. If it's in the heart, congestive heart failure. It's in the brain, Alzheimer's-like dementia. But it's all the same process. It's all sugar. Interestingly, people are starting to hear about this now. There's this pediatrician at UCSF a few months ago got on the national news, sugar should be regulated as a toxin. Of course, his career is gone because the sugar industry didn't want to hear that. But they don't understand why they're trying to communicate this, because they're looking at obesity and stuff like this, instead of stepping back and looking at the whole picture. Because today we know that aging pretty much is rusting from free radicals and protein wrinkling from sugar. You can pretty much reduce it to those theories. That's it. We stumbled into the memory reversal thing working backwards from what we saw clinically to the sugar toxicity thing. But that's what I think is going on. Interestingly, there is a lab test that can be done. It's called a hemoglobin A1C test, or a glycohemoglobin test. And what that test measures is it measures the sugar coating on the surface of the red blood cell. As those cells get older, and remember, 1/4 of the cells in the human body are red blood cells. As that glycohemoglobin builds up, the hemoglobin A1C goes up. And that test was originally developed to use for diabetes, because in the old days, we'd play games with diabetics where they'd be on their insulin, whatever, everything looks good, and they're out there eating cake, pies, whatever they're doing. And about 2 weeks before they saw the doctor, they'd tighten up on their diet. We'd measure their blood sugar, it'd look good. Everybody's happy, hey, you're doing good. They have the heart attack. Today we have a hemoglobin A1C test. You can't fool that test. It measures your blood sugar for 3 months. So you can't fool the test. But it's a direct measure of molecular aging, and today in the current literature, it's a very, very strong risk factor for heart disease, but the cholesterol folks can't understand why, because they're still focused on cholesterol, not on the sugar toxicity. So we happen to be caught in this odd time in science where the old flat earth type theories, the fat toxicity of cholesterol, is going the way of the Flat Earth Society. It's not correct. But there's so much money being made with the cholesterol-lowering drugs and the bypass surgeries and the angioplasties and the stenting and stuff, nobody wants to hear there's another theory.